Let's take a look at inverse sine functions. So with inverse sine functions, we are given theta and given x and have to find theta. So sine to the negative 1 of x equals our angle. So x, we only take inverse of ratios. So x in all of these instances is going to be some sort of ratio, some sort of number. We will get out of it an angle. Let's take a look at some of these examples. Oh, another important note before I move on. Remember, sine to the negative 1 of x is not 1 over sine of x. That is a completely different thing. That is the reciprocal of sine of x. The way you would write that is sine of x to the negative 1 power. That is the reciprocal. This is the inverse, and that's where we're trying to find an angle. So let's look at problem 10. Given sine of 5 pi over 12 is approximately 0.96593, write a relation involving the inverse sine. So what they're asking for here is how can we use the inverse sine to give another equation? So what we're going to do is the inverse sine of this ratio, that decimal is a type of ratio, is equal to the angle, the radian, 5 pi over 12. Evaluate each of the following. So we have a ratio and we have an inverse sine function. What do we take the sine of to get 1/2? Can you remember? Well, I know it's one of those special triangles that we talked about. Let's take a look. So if we're looking at I'm going to draw better. A 30, 60, 90 triangle. Our hypotenuse is 1. Our shortest side is 1/2. This side is square root of 3 over 2. Which angle would we be taking the sine of to get 1/2 over 1? Which one is opposite of 1/2? 30 degrees. So 30 degrees is the inverse sine of 1/2. How about the negative square root of 2 over 2? So we know that sine equals y over 1. So our y value has to be negative. So on the coordinate plane, when we're trying to figure this out, it has square root of 2 over 2. That leads me to believe it's some sort of 45-degree angle. So y is negative here. Y is negative here. So if this is 45 degrees, and this is 45 degrees, we have 1, 1, square root of 2 over 2, square root of 2 over 2. So the inverse sine of square root of 2 over 2. It could be either of these angles. Remember, our angle starts at standard position. It starts right here and goes counterclockwise. So it's going to be 180 plus 45. So what's 180 plus 45? 225 degrees. That's our first angle. What about the other angle it could be? It could also be this angle. Now what's that angle? So this is 90, 180, 270 plus 45 degrees. So it could be 225 degrees and it could be 315 degrees. If you're not sure about your answer, go ahead and pull out your calculator. If you have inverse sine functions in here, go ahead and use them if you want to check them that way. What I'm going to do is I'm going to take 225, take the sine of it, and we get a negative number. Negative square root of 2 over 2. We can actually look at that. And it is that 0.07, so that's perfect. Now let's try sine of the other number, 315. Oop, I gotta clear that out. So see here, 315, take the sine of it, and we also get that negative 707. So some of these could have multiple answers. What about this next one? Let's do another coordinate plane. Square root of 3 over 2. Now looking at this triangle that we had been looking at up here, we're looking at square root of 3 over 2. But we're looking at cosine, so it has to be adjacent. 30 degrees is what's adjacent to square root of 3 over 2. It's negative square root of 3 over 2, and we are talking about cosine. Cosine x is negative, so it has to be here or here. So 30 degrees or 30 degrees. Whoop, I don't know why it disappeared on me. It looked so pretty before. All right, so it's going to be one of those angles. It's either going to be this angle here or this angle here. So what's this first black angle? That angle is 90 plus 60 is 150 degrees. What's the red angle? 180 plus 30 is 210 degrees. So let's take a look at our calculator and see if it matches up with our sines. So we're going to take cosine of 150 degrees. Oh, I gotta clear stuff out again. 150 cosine is negative. Perfect. 210 cosine is negative. Awesome. So that's going to be our correct answer. Inverse tangent of 1. What gives us a tangent of 1? That is when we have our y equal to our x. Our y is going to be equal to our x here, 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 and here. These are all 45 degrees away from each other. However, our x and y have to have the same sign in order for it to be a positive one. So it can't be this guy, and it can't be this guy. So it's going to be one of these two angles. It's either going to be straight up 45 degree angle, or it's going to go all the way around and be that angle. So our first one's easy enough to figure out, 45 degrees. How about the other angle? So we have 180 plus 45 is going to be 225 degrees. Let's see if that matches what our calculator says. Oh, I gotta clear this out. 45 tangent is 1. 225 tangent is 1. So that is correct. Let's evaluate inverse sine of 0.97 using a calculator. I'm not entirely sure my calculator does inverse sine, so I'm going to pull out my calculator that you can't see and use that instead. I'm using a TI-84. In our inverse sine, you hit second sine 0.97, and you get 75.93 degrees. Solve the triangle for angle theta. So we're trying to figure out what this angle is right here. We know the adjacent and the hypotenuse, so we can use cosine to figure this out. Cosine of theta is equal to 9/12. Now, in order to get theta all by itself, we have to take inverse cosine of both sides. So cosine of cosine equals inverse cosine of 9/12. Now remember, when we take the inverse function of another function, we just get our original input. In this case, it's theta. So the cosine and inverse cosine cancel each other out. So theta equals the inverse cosine of 9/12. So you can put that into your calculator. Second cosine, 9 divided by 12, and you'll get about 41.4 degrees. You can scroll down, you can do problem number 11, and I'll wish you the best of luck there. Reach out to your instructor if you have any questions, and our next stop is going to be vectors.